Stocks occur at any point in the supply chain where the flow of materials is interrupted. Traditionally, it is kept in warehouses, and this gives a convenient label for any storage areas. In practice, there are many arrangements for storage, and warehouses might be open areas where raw materials like coal, ores, or vegetables are heaped, or sophisticated facilities that give the right conditions for frozen or delicate materials, or databases that hold stocks of information, or people who have a stock of skills. Reflecting the different physical arrangements, people use different names for the stores, with the most common being distribution centers and logistics centers. Often distribution centers are described as storing finished goods on their way to final customers, while logistics centers store a wider mix of products at different points in a chain. Other names such as depot and transit center suggest that they not only store materials but do some other jobs. To make things easy, we will use the general term warehouse to cover all kinds of places where materials are stored. Product should never be warehoused or stored but should continually be in movement with the least possible number of handling steps. This view reflects the common view that stocks should be minimized and preferably eliminated, but the reality is that warehouses remain an essential part of most supply chains. From an organization's point of view, there are two main types of warehouse: those linked to upstream suppliers in dealing with raw materials that are collected before operations, and those linked to downstream customers and dealing with finished goods during distribution to customers. So a typical configuration has materials arriving from suppliers and put into a raw materials warehouse, moving through operations, assembly, manufacturing, and then put into a finished goods warehouse before being sent out to customers, retailers, wholesalers. In addition, there are smaller stores of spare parts, consumables, and work in progress. Managers have the option of working without either both raw materials or finished goods warehouse. They can do cost analysis, and a warehouse is only attractive when its operating costs are less than the savings it generates. Warehouses in the supply chain strategy. Warehouses are expensive and they need careful planning. We already looked at some of the key decisions here. The logistics and supply chain strategy set the overall structure of the supply chain, including the role of warehouses. Location decisions show where to open them. Capacity plans show the number of warehouses to build and the size of each. Inventory management gives the materials to store and amounts of stocks. Now let's look at some related decisions. What jobs should we do in the warehouses? Who should own them? What is the best layout, equipment, and how to measure performance? As always, there is a hierarchy of decisions, with the logistics strategy leading to a series of tactical and operational decisions about the running of warehouses. For example, if the business strategy aims for high customer service, the logistics strategy will probably include more smaller warehouses. So warehouses must contribute to the logistics strategy, and this means that managers analyze the strategies, design warehouses that will support them, and then run these warehouses as effectively as possible. One approach to do this has the following steps. Analyze the logistics and supply chain strategy, setting the context and finding what the warehouse has to achieve. Examine current operations to see the failings and how these can be overcome. Design and outline supply chain structure, defining the best number and locations for warehouses. Make detailed plans, finding the size of facilities, stock holdings, material handling equipment, systems to develop people, transport, and so on. Get final approval, with senior managers agreeing the plans and funds. Finalize building design, purchasing land, choosing contractors, and building. Then finalize the systems design, designing the ordering, inventory control, billing, goods location, monitoring, and etc. Then fit out, installing all equipment, systems, staff, and testing. Open and receive stock, to test all systems, finish training, and begin operations. Sort out problems to get things running smoothly. And last step, monitor and control, ensuring that everything works as planned, measuring performance, revising incentive schemes, and so on. This is not a recipe and the steps are not done in strict sequence, but it highlights some of the important decisions. To develop a new warehouse always takes time, perhaps several years in total, and all of the questions can be difficult. For instance, the basic question of size obviously depends on forecast throughput, but it also has to allow for practical details, such as the number of products using the warehouse, the type of demand for each product, how much it varies, average order size, and so on. Physical features of the products, particularly size and weight. Special storage conditions, such as climate control, packaging, and so on. Target customer service level. Lead times from suppliers and promised to customers. Economies of scale. Type of material. Handling equipment. Layout of storage and related facilities. And the office space needed. The purpose of a warehouse is to support the broader logistics function by storing materials until they are needed, with a combination of low costs and high customer service. Specific objectives might include providing safe and secure storage at key points in a supply chain, keeping materials in good condition and with minimal damage. Efficiently doing the associated handling, moving, sorting, and checking of materials. Keeping accurate records, processing information, and transferring this as required by suppliers and customers. Adding value by doing other tasks that may be best performed in the warehouse, such as packing or finishing for postponement. Being flexible enough to deal with uncertainty, variations, special requirements, and so on. These objectives say what a warehouse might want to do, emphasizing its core function as a store of goods. And now we can see how it achieves this. All warehouses do similar activities, essentially receiving deliveries from upstream suppliers, storing them until they are needed, and passing them on to downstream customers. We can add some more details and get the following list of activities that are generally included in warehousing. Meeting delivery vehicles from upstream suppliers and directing them to arrival bays. Identifying the materials delivered and matching them to orders. Unloading materials from vehicles and checking their condition, quantity, and quality. Sorting goods and forming convenient units of storage. Labeling storage units so they can be identified. Moving storage units to a bulk storage areas. When requested by customer orders, picking materials from the store, checking them and consolidating them into orders. Checking, packing and packaging the orders. Moving the orders to departure bays, loading them onto delivery vehicles and dispatching them to customers. Controlling all communications and related systems such as inventory control and accounting. Organizations are increasingly trying to move materials quickly through supply chains without interrupting the flow or having them sit in stock. So the focus of warehouses has changed, moving away from long-term storage and towards giving convenient locations for a range of associated activities. The trend is clearly for warehouses to do more jobs, positively adding value. This is an important point as warehouses have traditionally been seen as pure cost centers. By looking at their ability to reduce overall costs, add value, and generally increase utility, managers can see warehouses as an asset rather than a necessary overhead. The broader role of warehouses has developed from their traditional jobs. For instance, they have always been the places where organizations do mass sorting of materials. Transport is often divided into full load and part load operations, and you might hear of truckload and less than truckload operators. Here, part loads are amounts that do not fill the transport used, so a part load might be a part of container, some of a tanker of liquid, or less than a full van load. Managers prefer full load operations because they are a lot easier to organize and give cheaper unit costs. This is the approach of containers, where the whole container moves on its journey through intermodal operators. Unfortunately, not all customers want full loads, and you can imagine them wanting several part loads of different materials from different suppliers. The best way of organizing this is to consolidate the part loads into fewer full loads. The practicalities are that the part loads are delivered to a warehouse where they are sorted and consolidated into full loads, and are then transported in full loads to the customer. The extra cost of sorting and consolidation in the warehouse is more than recovered from the reduced cost of transport. It may be difficult for a single company to consolidate loads in this way, but several companies working together could combine loads. More often, third parties organize the consolidation, and freight forwarders do this for global logistics. Freight forwarders might book a number of containers on a ship traveling between Hong Kong and Rotterdam, for example, and then consolidate loads from a number of companies around Hong Kong who all want to ship relatively small amounts. The forwarders make their money by paying full container rates and charging somewhat more than this, but obviously less than small road rates. A warehouse can do more jobs, including a limited amount of final assembly. A manufacturer might make the parts for a product in a number of factories in different locations, then arrange for all parts to be sent to a warehouse, which assembles the final product and delivers it to customers. As we have seen, this is the basis of postponement, where the final steps of production are left to the last possible moment. It also suggests that there is no rigid distinction between factories and warehouses, and that they are both part of the overall process of delivering products to the final customers. The opposite of consolidation occurs when warehouses break bulk. Here, a supplier sends all the deliveries for a particular area in a single load to a local warehouse. The warehouse breaks this load into the separate deliveries and passes them on to customers. Again, this brings the benefit of lower transport costs, which more than cover the extra handling. A long journey typically includes both consolidation at the start and then break bulk at the end. A package may go through this handling several times when it moves between different legs of a long and complex journey. With their declining role as long-term stores, an efficient way of organizing warehouses avoids actually putting materials into storage at all. This gives cross-docking, where the arrival of materials at a warehouse is coordinated with their departures to customers. Materials are received at an arrivals area and are transferred directly to the loading area and immediately sent for delivery to customers. In practice, there might be some delay, but this is usually less than 24 hours. There may also be a limited amount of sorting and rearrangement of materials for orders. The result is a reduction of operating costs of up to 30% and lower capital costs for warehouses that are much smaller and with limited storage facilities. The traditional view has each organization running its own warehouses. Each wants its materials nearby, so it stores them close to operations. Small organizations would find it prohibitively expensive to build their own warehouses. But we have made the point that these can be any storage areas rather than the huge buildings that you see by the side of motorways. Another option is to use facilities provided by specialized warehousing companies. This can benefit even large firms, so there is a choice between private and public warehouses. A private warehouse is run by the organization that owns the materials and forms a part of its internal operations. The warehouse may actually be owned by the firm, but there are different arrangements for ownership and leasing. The key point is that the firm that owns the materials runs the warehouses as part of its core operations. This has the benefits of greater control over a central part of the supply chain, closer integration of logistics activities, facilities tailored to the organization's needs, being in the right location, right size, fitting it with customer service, and so on. Easier communications with integrated systems throughout the company, lower costs without the profit needed by another organization. Possible tax advantages and developments, grants, enhanced corporate image, giving an impression of reliability and long-term dependability. A public warehouse is run as an independent business which makes money by charging users a fee. The provider might use spare capacity in its existing facilities, or for large operations it might build and run extra dedicated facilities. There are many different arrangements and types of public warehouse, including bonded warehouses, cold stores, bulk storage, tankers, general purpose, cross-docking, and some others. The facilities available are so flexible that an organization can get within reason any facilities it needs. There are also many arrangements for their use. At one extreme, a company might simply rent an area of empty space in a warehouse that it shares with other organizations. The company looks after all aspects of warehousing itself. At the other extreme, an organization might contract out all its warehousing operations to a specialist third party. Then the organization does none of its own warehousing, but specifies standards that the service provider must meet. Organizations are increasingly concentrating on their core activities and contracting out some of their logistics, so it is not surprising that there is a trend towards public warehouses. Firms are not limiting themselves to renting space in public warehouses, but they're also transferring the operations and responsibility to third parties. A more common arrangement outsources all warehousing, so that stocks are held and managed by a third party in public warehouses. When there is a long-term agreement or alliance between an organization and the service provider, this becomes contract warehousing. The main benefits of public warehouses are that flexible capacity can deal with changing demands, perhaps due to seasonality. Large capital investment is avoided, giving lower fixed costs and higher return on investment. Costs are directly related to the level of use. It provides skills and experience that firms do not have internally. It gives access to the latest technology, systems, equipment, and practices. It allows easy access to new markets and a wider geographical area. It allows short-term tests to assess new methods and areas. Economies of scale are used to reduce unit transaction costs. High quality and efficient service are guaranteed. These benefits have to be balanced against the loss of control. There is also some question of cost. Public warehouses might be efficient and large enough to get economies of scale, but they also have to make a profit and by definition generate more income than their costs. The choice between private and public warehousing ultimately depends on which can give the better service for the same or lower cost. This is often seen as a make or buy decision and is presented as a break-even analysis. Private warehouses have higher fixed costs but generally lower unit operating costs, while public warehouses have low fixed costs but higher variable costs, as shown in this graph. This gives a very simple view, and there are really many other factors to consider, including the following: operating costs. In different circumstances and depending on throughput and financing arrangements, either private or public warehouses might give lower unit costs. Capital costs. Capital is always scarce, and even when private warehouses seem attractive, it might be difficult to justify the heavy investment. Customer service. Organizations must have warehousing that gives acceptable customer service. Sometimes they find it impossible to get a third-party operator who can meet all their requirements, and then private warehousing is the only option. Control. An organization clearly has greater control over warehousing and logistics in general when it runs its own warehouses. Flexibility. Private warehouses tend to have rigid structure and operations, making it difficult to make quick adjustments in response to changing conditions. If there is a sudden peak in demand, they cannot increase the size of a warehouse for a few days and then reduce it again when the peak is past. Public warehouses handle these adjustments. Management skills. Managing a warehouse needs special skills, which are not readily available in even the biggest organizations. This gives a strong argument for public warehouses, as operators can provide management teams with the necessary specialist skills, knowledge, and experience. Recruitment and training. Warehousing is labor-intensive and has high employment costs. Many organizations finding it difficult to recruit and train with the necessary skills. After considering the benefits of both private and public warehouses, a common arrangement uses some mixture of the two. An organization uses private warehouses for basic core needs and then tops this up with public warehousing as needed. A rough guideline suggests that a warehouse with enough capacity to meet peak demand will only work at full capacity for 75 to 85% of the time. Then a sensible option is to have private warehouse with enough capacity for this 75 to 85% of the time, and then use public warehouses for the rest. With such arrangements, organizations can achieve occupancy rates of over 90%. An important decision in the design of a warehouse concerns the layout of its facilities. Layout describes the physical arrangement of storage racks, loading and unloading areas, equipment, offices, rooms, and all other facilities in a warehouse. The layout directly affects the efficiency of operations, as you can see in a library. When you visit a library with a good layout, it is easy to find the books you want, find somewhere to sit and read them, or check them out. In a library with a poor layout, you spend a long time trying to find your way around, cannot find things that are in obscure places, move long distances, and generally waste time. If a warehouse keeps a frequently used product a long way away from delivery and departure bays, it wastes time whenever the stock is used. Layout decisions are important for three basic reasons. First, they require substantial investments of both money and effort. Second, they involve long-term commitments. And third, they have significant impact on the cost and efficiency of short-term operations. People have different views on layout, but there are some simple guidelines for warehouses. Apart from the normal requirement for any building to be safe, functional, energy efficient, durable, allow for long-term needs, and so on, a warehouse should put everything on the same floor, as moving between floors is difficult and wastes time. Only use mezzanine floors for administration or some sorting. Separate arrivals areas and departure areas to reduce congestion and avoid confusion. Plan the layout to give a smooth and easy flow of materials into, through, and out of the warehouse. Simplify movements, eliminating or combining separate movements where possible. Make movements in straight lines. Use efficient and appropriate material handling equipment. Have high-level storage to reduce the area using all the height of the building. Have offices outside the main storage area. A space above them is wasted. Notice that these guidelines emphasize the use of all the available volume. The costs of running a warehouse are often proportional to the floor area that it covers, and they can be reduced by making the building taller. However, the extra height has to be properly used. Then it makes sense to judge performance not by turnover per square meter, but by turnover per cubic meter. Within such general guidelines, we can now look in more details at the layout. You can see the main principles of layout every time that you go into a supermarket. Then materials are delivered at the back of supermarket. They are sorted and put onto the shelves in the middle. Customers pick items they want and take them away from the front. So the five basic elements in a warehouse, as illustrated in this picture, are an arrival bay or dock where goods coming from suppliers are delivered, checked, and sorted. A storage area where the goods are kept in stock. A departure bay or dock where customers' orders are assembled and sent out. A material handling system for moving goods around. An information system which records the location of all goods, arrivals from suppliers, departures to customers, and other relevant information. There are many variations on this basic pattern designed to suit specific circumstances. Perhaps the most common version actually has two storage areas, a box storage and a picking store. When goods arrive, they are put into a box store, which is the main storage area. The packages in the box store are broken into individual units and moved to a small picking store that is used to assemble orders. When customers send an order, the items needed are picked from the smaller picking store and brought together in a consolidation area before moving to the departure base. When stocks in the picking store run low, they are replenished from the box store. This gives the flow of materials from arrivals bay, box store, picking store, consolidation area to departure base, and so on. Supermarkets have this pattern with a stockroom giving bulk storage, shelves in the top as a picking store, the checkouts at departure base, and so on. But supermarkets are not typical warehouses, as they have fundamentally different aims. Warehouses want the picking and movements to be as fast as possible, with goods moving efficiently to the exit without any delays. But supermarkets want their customers to pick goods slowly and move around the whole store before heading towards the exit, as the longer customers remain in the shop, the more they buy. Variations on this theme include different types of storage within the warehouse. For instance, big items are commonly held in different areas from small ones, simply so that bigger handling equipment can get around. Then big items are spread out so that forklift trucks can move freely, while small items are put on close packed shelves so that people can reach them without moving far. Another distinction has weather-resistant goods, such as concrete pipes, left in the open, while the delicate materials are kept in an expensive building. More specifically, products that need similar handling are put in the same area, such as frozen foods, liquids, dangerous chemicals, or prescription drugs. In this and next lectures, we're going to show some space calculations about different warehouse areas. These calculations are based on experience and are not intended to provide definitive answers to space requirements. The first area is receipt and dispatch areas. It is sometimes overlooked in favor of storage space. However, this is one of the most important areas in the warehouse. The warehouse operations rely on sufficient space both inside and outside the dock base. Getting the right balance between the number of doors, equipment, and labor is difficult to achieve and requires the coordination of arrivals and departures with available resources. A congested dock area can result in arrival and departure delays, lost or misplaced products, incorrect dispatches, or damages to the products. The following basic formula can be used to calculate the likely space requirement for staging vehicles on arrival and departure. So we have the number of loads, hours to unload, time to shift, multiplied by the number of pallets by the space per pallet. For example, if we receive 20 vehicles per day, 26 pallets per load, with a pallet size of 1.2 by 1 meter, and it takes 45 minutes per load to unload and 30 minutes per load to check. We operate an 8-hour shift. So you see the calculation, and here the answer is 124.8 square meters, and we round up all the calculations here because we don't want to be short of warehouse operators of time, so that's why everything is rounded up here. In addition to this space, we need to add working and travel space around the pallets. This space will be determined by the type of forklift or pallet truck used to unload and load the vehicles. Potentially this can more than double the amount of space required for the pallets and depends on how much access to the pallet is required. The ability to preload trailers will reduce the amount of space required at the dispatch bay. If we have sufficient doors or yard space to accommodate the number of loaded trailers. The ability to double stack pallets will reduce the space required, but will also limit the type of pallet truck utilized. There may also be a requirement for a cross-dock area where goods having been received into the warehouse but not put away are to be dispatched en bloc to a customer who has yet to collect the goods. This could take anywhere between a day and a month to dispatch. Under these circumstances, it may be prudent to use drive-in racking in the dispatch area, for example, to minimize product damage. Calculating the amount of storage space required and the storage medium depends on a large number of factors. Each item needs to be evaluated and a table produced to record the different item properties and as a result to decide on potential storage medium. Having calculated the amount of items stored per product line and converted these into pallet quantities, we are able to calculate the total number of pallets we need to store by product line. Once this has been calculated, we should produce a chart detailing the number of pallet locations required and the height requirements for each location. Depending on the nature of the product in terms of weight, crushability, etc., it is likely that the pallet heights will vary between products, and some products may only require bin storage, for instance, as the quantities are very low. The next decision is the type of storage medium to use. This can include block stacking, pallet racking, automated storage shelves or bin locations, or some combination of some of these or all. Having produced a basic formula for calculating dock space, there is a formula to calculate the number of pallets that can be stored within a given cubic area when using standard adjustable pallet racking. And here is the formula for total pallet capacity. We have the number of width modules and pallets inside, number of length modules and pallets, and the number of height modules. And here we have the formulas for each part of this calculation. For module width of the aisle, plus 2 pallet lengths, the short side, and plus the clearance between back-to-back pallets. For the length, width of upright, plus 3 times clearance, plus 2 pallets the long side, and the height of the pallet, and clearance above pallet plus a racking beam height. Let's continue with a simple example for the space calculations we just talked about. For example, based on the following dimensions: aisle width, pallet size, width of upright, clearance, sides, height, back to back, warehouse height, storage area length, and storage area width. If we use the formulas we discussed in a while, we can calculate first module width, length, and height, and then the number of modules, and at the end the total pallet capacity, which here is 9072. So therefore, in a cubic space of 120 meters by 48 by 10 meters, we have a capacity to store 9072 pallets based on an overall pallet dimension of 1.2 by 1 by 1.35 meters, and utilizing a reach truck working within an aisle width of 3 meters. The number of pallets that can be stored in this particular area is determined mainly by the aisle width, type of racking, and the size of pallet. As we said, this is just a basic calculation, and there are some other factors that need to be taken into consideration before using those figures. The calculations take into account the aisles between the racking, but do not take into account aisles and gangways at the front of the racking. They also do not take into account potential pallet overhang, walkways, or fire exits. Here are some other factors that need to be considered into account are pallet utilization within the warehouse. It is known that once storage utilization exceeds 85%, productivity and safety decline. The operations will slow as put away is delayed while space is being freed up. The presence and locations of roof columns. Storage equipment manufacturers will take this into account when producing the plans. The requirement for space between the backs of pallets and at the sides of the pallets. The presence and locations of sprinklers, either ceiling or in the rack. The overhead pipes and sprinklers will limit the height both within the warehouse and within the racking itself. The type of lighting utilized and any heating or cooling systems installed. Lift height of the forklift truck. Different types of forklifts will have different lift height capabilities. Also, pallet orientation, either short or long facing. How a pallet is stored within the racking has its own trade-off within the warehouse. Storing a pallet with the long face parallel to the aisle makes it easier for operators to pick, not having to stretch too far across the pallet. However, storing the pallet with the short side parallel to the aisle means greater flexibility and more pallets can be stored in a length of racking. The requirements for cross aisles within the racking to reduce travel and the need for walkways between the end of the racking and the wall to provide escape routes for the staff or fire exits. And lastly, the type of racking. For instance, double deep racking will reduce the number of aisles required, while narrow aisle storage requires less aisle width. A crucial aspect of warehouse layout is aisle width. This is the distance between pallets in adjacent racks. To ensure safety, we need to calculate the distance between the pallets once they have been put onto the racks. The aisle width is determined by the turning circle of the forklift truck and the size of pallet being carried. Exceptions to this are narrow aisle and turret trucks, which operate in aisles which are based on the width of the truck itself, while articulated forklift trucks calculate aisle width based on the distance diagonally across the pallet or from one corner to another when a pallet is being rotated in the aisle. A safety clearance of 100 mm either side of a typical pallet will need to be added to ensure fast pallet put away and retrieval. The second dimension is the overall width of the truck chassis when traveling along the stacking aisle. Manufacturers of forklift trucks will provide recommendations on the minimum aisle width required for their trucks. Deciding on the optimal aisle width is a critical part of an overall storage or materials handling strategy. Aisle width decisions need to achieve the best combination of productivity, space utilization, flexibility, safety and equipment costs for the specific application. Other factors include the depth of the pallet on the truck and whether there is a requirement for 2 trucks to pass in the aisle. The decision will also require the user to decide whether speed or storage capacity is the main driver. The advantages and disadvantages of each type of racking system we are going to discuss in more details in the next section. And now let's see what are some other areas to consider in the warehouse. The amount of space set aside for packing, value-adding services, and returns processing will depend on the level and the type of activities envisaged within the operations, the number of staff, and the type of equipment required. An area that is regularly neglected when calculating space requirements in the warehouse is the area needed to store, recharge, and change batteries for forklifts, a packing area for equipment when not in use, an area for storing empty pallets and packaging, and an area for ancillary equipment such as stretch wrap machines, pallet inverters, etc. Office and restroom space will be determined by the number of employees required within the warehouse. Finally, we need to ensure that we have sufficient space outside the building for the following activities: to park vehicles, for on-fleet vehicles, sufficient turning circle for the largest ones, waste and recycling areas, areas for weather-resistant packaging, and also parking for staff and visitor cars. There are many different forms of racking systems available on the market today. Each one performs a different role, and its use will very much depend on the type of operation in the warehouse. In terms of storage systems, we come across another warehouse trade-off, and it is between speed, cost, and capacity. The greater the storage an operation requires, the greater the density of pallet storage needed. There is, of course, no right answer to the type of storage that should be used. The type of storage will depend on the configuration of the building, the type of mechanical handling equipment currently in use, and of course, on the budget available. Here are some storage options. First one, block stacking. In case where the warehouse height is reasonably low, where products and packaging are robust and budgets are tight, this type of storage is the most common method of storing large quantities of single SKU products. The goods are packed in unit loads and stacked on the floor to their maximum safe height, which is governed by the weight and stability of the stack. This method is also used where products do not lend themselves easily to palletization and pallet racking is out of the question. Block stacking is a cheap way to store robust products where there are a large number of units per SKU. Of course, there are a number of disadvantages associated with block stacking. Access. Sufficient space needs to be allocated for forklift trucks to access each stack. Also, in order to access the bottom pallet, you need to move the pallet above. Damage. The items at the bottom can be crushed by the weight of the items above. Care needs to be taken with the number of unit loads stacked on top of each other. Stock rotation. Unless product can be accessed at both ends of the stack, items can only be dispatched on a last-in, first-out basis. Space utilization. Here, utilization can be very poor if stock does not move quickly through the warehouse. Picking stock from either the front or the rear of the stack can lead to unusable storage areas being left. Cubic utilization also tends to be poor when block stacking items where the clear height of the warehouse is significantly higher than the stack itself. Racked storage. The terms adjustable pallet racking and white aisle racking are seen and looked as interchangeable. White aisle or selective pallet racking. This racking is present in the majority of warehouses today. It is the most versatile of any racking without the need for any specialized handling equipment. The beam heights can be configured to any height as required. The racking can also be configured to take pallets in either long side or short side configuration. Every pallet is accessible at any time, and the racking is easy to install and, if necessary, to move. The disadvantages is in the fact that wider aisles are required to allow the forklift trucks sufficient turning circle. The use of reach trucks in this area reduces the amount of aisle width required compared with counterbalance trucks. Double deep pallet racking allows pallets to be stored too deep in the racking, in this way eliminating an aisle. The pallets are still accessible from the same aisle. The system does require specialist equipment in the form of extendable forks and will require slightly wider aisles. Narrow aisle racking utilizes adjustable pallet racking and provides storage for greater concentration of pallets by reducing the aisle width to around 1.6 meters. Drive-in, drive-through racking. It provides a safe and efficient equivalent to block stacking for loads that are too fragile or unstable to be stacked on top of each other. With this racking, there is no requirement for aisles, therefore floor space is fully utilized. Cubic space utilization will depend on the lifting height capability of the forklift truck. Drive-in racking does not allow for first-in, first-out system. However, drive-through racking does enable you to extract pallets from the other end of the racking. This reduces the amount of storage space available, however, and also adds to the honeycomb effect as well. Drive-in drive-through racking is a high-density storage medium suitable for large quantities of single SKU. Its disadvantages are the increased potential for damage not only to the product but also to the racking and the low speed of put away and retrieval. The next type of storage equipment we're going to talk about is pallet flow or live storage. Pallet flow racking is driven by gravity. It is perfect for fast-moving products with first-in, first-out stock rotation. Pallets are loaded at the upper end of sloping lanes and moved down by gravity using heavy-duty skate wheels when a pallet is removed from the pick face. Pushback systems work by placing pallet loads on a series of nesting carts fed forward by gravity on rigid structural steel rails. As a pallet is loaded from the front, it pushes the pallet behind it back one position. When unloading, the front pallet is removed and the rear pallets automatically come forward to the front picking position. This allows for easily accessible last in, first out inventory management. Where floor space is very expensive, a warehouse can be made very compact if the units of racking are movable by being mounted on rollers. Only enough space for one access aisle is then required, as the operator can move the aisle simply by moving the units, by power, by hand wheel, or by pushing, to create a way through to a particular bay. But here, of course, floor space is being saved at the expense of a slowing down in the load retrieving operation. A recent development into the pallet storage market is satellite or shuttle racking. A satellite system is similar to drive-in racking. However, it is operated by placing shuttles at the front of the racking utilizing counterbalance, reach, or narrow aisle tracks, depending on the height of the racking. The shuttles are controlled remotely through a radio frequency battery-operated control system and special channel rails. There are no aisles and therefore the cube of the warehouse is well utilized with use of very long lanes. The storage system can store pallets within a system that can operate to lengths of 40 meters. The racking features guide support rails that run the depth of the rack's structure on which an automated shuttle travels. Pallets are loaded onto a shuttle at the front of the lane, which transports the pallet down to the other end. The built-in sensors on the shuttle detect the position of existing pallets and place the new load at a predetermined distance before returning to the start. The shuttle is easily moved between lanes by the forklift trucks. Multiple shuttles can be controlled by one forklift truck. High bay warehouses. These consist essentially of massive blocks of racking built as an integral structure to a high degree of precision and often acting as a support for the building's roofs and walls. Warehouse heights can range from 23 up to 60 meters. Cranes built into the racking structure operate in aisles little wider than the unit load handled under computer control, with the unit loads moving automatically into and out of the racking. The costs are very high, but so are space utilization and operating efficiency, and there is little doubt that more of these warehouses will be built to handle and provide quick access to goods where the range of products is wide and stock turnover is high. Where a warehouse has sufficient height, it can be very cost effective to construct a mezzanine floor or a raised storage area. Typical areas are above the inbound and outbound loading bays. This space can be used to construct shelving for storage that can also be used to undertake value-adding services or can be used for long-term storage. Here is a chart that shows and gives you an idea how to choose the storage equipment. It is drawn as a decision tree, so you could have a look at it and you can use it when you decide what type of storage equipment to use. There is also an attached file to this lecture that you can see when you download it, the comparison between different types of racking systems, its advantages, disadvantages, when to use them. So feel free to download this file. Let's continue with two lectures about handling equipment. The challenges of a 24/7 operations culture, together with an constantly aging workforce, demands for improved accuracy, shorter lead times, and a reduction in cost, have pushed manufacturers into producing handling systems that require minimal manual input and provide increased throughput levels. The key principles of materials handling are: continuous movement is most economic, economy is directly proportional to size of the load, standardization reduces costs, mechanization improves efficiency, gravity is cheap, and simplicity is the goal. In choosing the correct equipment, we are looking to lower unit materials handling costs, reduce handling time, conserve floor space, prevent injuries to staff, and reduce energy consumption. It is essential to consider all aspects of an operation in order to ensure that the most suitable equipment is specified and the best handling solution selected. Important factors include the load and the means of transfer, the type of storage, the type of operation, warehouse dimensions, height travel, overhead obstructions, surfaces and gradients, working area, and the environment. Now let's look at different types of handling equipment. First, for horizontal movements, a hand pallet truck has a pump to enable the operator to lift a pallet sufficiently to be able to move it across the warehouse floor. It is a cost-effective piece of equipment to move pallets across short distances. It can also be used to maneuver pallets within the racking or on the back of a trailer or container. Powered pallet trucks, they are battery operated and are used for loading, unloading, picking and pallet transfer duties to and from the receiving and dispatch areas. They can be supplied as pedestrian, stand-on or seated versions. The choice of truck will depend on pallet throughput per hour and distances traveled within the warehouse. Tow tractor or tugs are utilized where distances between points within the warehouse are long and there is a requirement to move a number of pallets at the same time. The use of automated guided vehicles is growing in popularity as companies struggle with a shortage of skilled labor, high labor costs, and around-the-clock operational requirements. If you couple this with a reduction in cost, AGVs become a feasible alternative to man and machine for moving pallets horizontally throughout the warehouse and for loading and unloading palletized vehicles. There are many types of AGVs. They might be wire-guided, magnetic. They can also could use cameras to record the movement and to memorize them for the next trip. Also, by combining voice speaking with laser-guided trucks, productivity increases can be up to 80%. The advantages of automated vehicles are that they are computer or hand-controlled, more durable than people, long distance and high density traffic, fitted with security sensors and guards, limited potential for damage, they are reliable and do not cause bottlenecks. The disadvantages are that they are initially expensive, fully reliant on the radio frequency system within the warehouse, and may require a specially designed and obstruction-free floor area. In order to take advantage of the cubic capacity of a building, pallets or unit loads need to be lifted into position. Forklift trucks are differentiated by their lift height capability, weight capacity, and turning cycle. Pallet stacker is used for moving pallets around the warehouse and when required can lift pallets up to 5 meters. They can be pedestrian, ride-on, stand-in or seated. Counterbalance forklift trucks are the most common trucks to be found in a warehouse. They are fast, flexible, and versatile, but the major disadvantage is that in order to stack or retrieve a pallet, they must approach the face of the pallet at 90 degrees. In this way, the turning circle of the truck determines the minimum aisle width. Counterbalance trucks can carry palletized goods to and from racks up to 7 meters high and require aisles of 3.5 meters or more in width. Reach trucks are ideal for working with narrower aisles. Unlike the counterbalance trucks, they carry the load within the wheelbase. They are able to work in aisles of around 2.7 meters. However, most companies will increase the aisle width to 3 meters. They have a maximum lift height of up to 12 meters and can operate in single and double deep racking environment. Narrow aisle are designed to operate with little more aisle space than their own width. The normal width of a narrow aisle truck is approximately 1.6 meters. Operating this type of truck can add approximately 33% to storage capacity through the adoption of narrower aisles. Articulated forklift trucks. The introduction of those trucks has overcome a number of issues, including the flexibility of being able to operate the same forklift truck inside and outside the warehouse. Training can potentially take longer than for an equivalent truck, and put away and retrieval times will vary depending on the ability of the driver. Articulated forklift trucks load and unload vehicles and deliver pallets directly to the racking in a single operation. By doing so, they increase efficiency and productivity while abolishing double handling and the costs associated with running a larger truck fleet than is necessary. Automatic storage and retrieval systems. These systems utilize fixed path cranes to collect pallets at the front of the racking system and transport them to empty locations within the racking. In order to improve productivity, the system collects a full pallet from the racking and deposits it at the front of the aisle prior to collecting another pallet. This dual command system or task interleaving is very efficient. The crane can travel horizontally and vertically simultaneously, reducing travel time between pickup and put down. There is a resource file attached to this lecture. You can download it. It provides plenty of data to enable you to compare the different pallet movement trucks. Not all unit loads can be moved or picked up by standard pallet forks. There are a number of operations and products stored within a warehouse which require specialized handling equipment. Here are some examples. We might need extended forks, crane attachments, boom attachments, drum grip and clamps, load clamps or carton clamps. In this lecture, we'll look at how operations within the warehouse affect the environment and how the warehouse can play its part in reducing carbon emissions. The figure shows the energy usage within an average-sized warehouse of circa 15,000 square meters. As can be seen, one of the main areas of energy use in the warehouse is heating and lighting, with research showing that the sector could potentially achieve a 16% reduction in emissions in these areas. The table outlines the key areas and low capital cost actions to reduce energy consumption and carbon dioxide emissions within the warehouse. Some of them include turn lights off in warehouse when an area is unoccupied, or turn lights off in warehouse when daylight is sufficient. Also, you can install lighting controls, clean or replace roof lights, and control space heating systems effectively, ensure efficient control of air conditioning, etc. In order to realize these savings, a number of things need to happen. These include undertaking a lighting survey to assess which lights are controlled by which switches, labeling the switches so that people know which switch controls which lighting, advising shift supervisors and team members that they need to turn these lights off when the area is unoccupied or when the area is sufficiently naturally lit. Purchasing a lux meter so that staff members can recognize what is the minimum level of lighting that is required. Installing suitable controls and luminaries. Cleaning or replacing roof lights, cleaning or replacing glass roof panels. Ensuring heating and air conditioning systems are working effectively, if not, replace them. installation of comprehensive insulation, also the efficient use of daylight when constructing new buildings. The self-production of energy is a potential option for warehouse operators to consider when looking to offset their carbon dioxide usage. Photovoltaic panels and small wind generators are still not cost efficient, but combined with subsidies and other government incentives, they can have a reasonable return on investment. Wind turbines and the production of energy from biomass can also be a viable way to generate low life cycle emissions at an acceptable cost. Waste is something which the holder or producer discards. If something is discarded, then it will remain waste until it has gone through what is known as a recovery operation. If you store, treat or dispose another person's waste, you need to hold an environmental permit. It is an offense to store, treat or dispose of waste without either an environmental permit or an exemption. There is also personal responsibility on directors and managers to ensure there is no breach of the legislation and they can be prosecuted personally. A holder of waste has a duty of care to ensure it is deposited or transferred to an authorized person. Overall, to comply with the duty, you must take reasonable steps to prevent the escape of waste whilst you hold it, transfer it to an authorized, suitably licensed person, provide written information which identifies and describes the waste being transferred. Packaging. Product packaging has a significant impact on the sustainability of the supply chain as a whole. There are three main types of packaging. Primary, sales packaging. This is the packaging around a product at the point of purchase by the user, consumer. Examples include bottles, tins, plastic covers, or wrapping. Secondary group packaging. This packaging groups a number of items together until the point of sale. Examples include an inner or outer box and strapping, which binds a number of items together. Tertiary transport packaging. This packaging allows handling and transportation of a number of grouped items as a single unit load. Over recent years, the mainstays of returnable transit packaging, the wooden pallet and metal stowage, have been joined by many other forms. These include plastic pallets, tote boxes, and metal cages. There are many reasons for reducing packaging costs. These include lower packaging costs mean higher profits, waste minimization benefits your own company and the environment. By carefully segregating its waste into cardboard, plastics, and general waste, one food contract packaging company reduced its waste removal cost by 45% and is now recovering approximately 30% of its packaging. It is possible to significantly reduce packaging costs and cut waste levels by implementing relatively simple measures, many with low or no associated costs, or if there is a cost, payback is relatively quick. Taking action on waste packaging will increase overall profitability, increase staff awareness of environmental and cost-saving issues, develop closer relationships with suppliers and customers through shared benefits and cost savings, reduce the use of finite resources, reduce the volume of waste going to landfill, reduce product damage, enhance environmental performance, promote a better company image, and meet current and future obligations under packaging waste regulations at least possible cost. Although the majority of waste initiatives begin at the design stage and are mainly the concern of the production department, the warehouse can have a significant influence on the amount of packaging used. When designing product packaging, there needs to be an input from the warehouse operation. For example, secondary packaging needs to fit the actual pallet dimensions. Any overhang on the pallet can lead to packaging damage, an increase in the amount of stretch wrap required, and potential issues when the product is put away in the racking. Although the mainstay of transit packaging over many years, the pallet can be replaced or at least augmented by other forms of tertiary packaging. For example, an alternative for the use of pallets where the products are lightweight in design include slip sheets and corrugated trays. Not only do they reduce the use of wooden pallets, but they are lighter, take up less space in a container, for example, and are significantly cheaper, especially in circumstances where pallets are not returned. Utilizing recycled pallets have a number of advantages over new pallets. They are likely to be cheaper and potentially stronger as a result of seasoning, which increases the strength of the wood. They are also exempt from packaging waste regulations. Suppliers can end up using excessive stretch wrap to stabilize product on a pallet. Alternatives include banding. Although a capital purchase, stretch wrap machines can reduce the usage of wrap and make the unit load more stable. As with many of the topics we have discussed in relation to the warehouse operation, packaging again results in trade-off. A significant trade-off is the strength of the packaging and potentially less damage versus the additional cost of the packaging. When picking individual items from secondary packaging, there is going to be a surplus of cartons. Where possible, cartons should be reused. If packaging cannot be reused, look to reduce disposal cost by segregating the waste correctly and, where feasible, selling it to waste recyclers or reprocessors. You can also set it against the purchase of packaging recovery notes. Something is hazardous if it is dangerous to people, animals, or the environment. You should first check the goods are as stated in the consignment transfer note and follow your own acceptance criteria. If the goods are later found to be hazardous, you may become the producer of the hazardous waste and will need to comply with the legislation governing this specific waste type. Electric lift trucks are superior to internal combustion engine models when it comes to the environment. Indoor air quality is improved by eliminating internal combustion exhaust within a facility. If utilizing electric lift trucks, it is not necessary to vent outside air into a facility to offset internal combustion exhaust or to exchange air as frequently through heating, ventilation, and air conditioning systems, which is good for the environment and has the added benefit of reducing heating and air conditioning costs. If electricity is generated by renewable sources such as wind and solar power, then electric lift trucks are truly emission-free. However, the environmental impact of an electric truck is more than just being emission-free. Electric trucks use no engine oil, transmission fluid, radiator fluid, or filters that have to be changed on a regular basis. These waste items can be very harmful to the environment if they are not handled and disposed of properly.